Hello, everyone, and welcome to the show. I'm Dr. Ralph Ford, Chancellor of Penn State Behrend, and you are listening to Behrend Talks. My guest today is one of our faculty members, Dr. Paul Lynch. Paul is an Associate Professor of Industrial Engineering. Welcome to the show, Paul.
Thank you, Ralph.
Thanks for being here. Well, and I'm going to read a little bit about your background. I hope we make you blush a little bit with all the great things that you're doing, because you have recently landed a very significant grant. Paul is the lead researcher on a $4.4 million partnership with the Institute for Advanced Composites Manufacturing Innovation. And when you put all those letters together, you get IACME, so we'll call it IACME, again, Advanced Institute for Advanced Composites Manufacturing. And in partnership with the U.S. Department of Defense, you are planning to, and we're going to go into a lot more detail, create a workforce development programs, including manufacturing boot camps that will support the U.S. metal casting and forging industries. And a little bit about your background. You hold a bachelor's, a master's, and a PhD, all in industrial engineering, all from Penn State University. Your research is on metal casting materials and manufacturing. You've won some really nice awards here at Penn State Behrend: the Council of Fellows Excellence in Outreach Award, the Excellence in Teaching Award, and the Guy Wilson Award for Excellence in Academic Advising. By the way, that's 3 out of the 4 major faculty awards we give here, so that's incredible. You're spending this summer, actually, I know you're here on campus today, but you've been at Eglin Air Force Base participating in a research fellowship program, your 7th research collaboration with the U.S. Air Force. You know them well. Again, welcome. So, really impressive background. So let's just start from the beginning. You were involved in material science, metal casting. Tell everyone what's this about? What interested you? What is it that you like to focus on?
Yeah, so specifically, again, thank you, Ralph, for having me here today. This means a lot, this talk to me. So specifically, kind of question is, what sparked my interest in this? I'm going to go back to how I grew up. So my brother and I are first generation immediate family college graduates. And we grew up in a hardworking blue collar community in the anthracite coal region of Pennsylvania, in Schuylkill County. Gordon, where we grew up, the borough where we grew up, was approximately 700 people. Our father was a mechanic. My mother is a beautician. So the local manufacturing plants, they were truly the economic engine for the region, for these small coal towns. And although there were some more, I remember 3 main manufacturers growing up in our immediate area. One was a lumber manufacturer, one was an envelope manufacturer, and we had a large local foundry, a metal caster. And really, that foundry probably had over 400 employees. Mm-hmm. They were good paying jobs with health care, training for the employees. They're family-sustaining jobs. Mm-hmm. And it seemed like somebody from every family in the region worked there. And it truly was the anchor for the region, and it really helped families realize the American dream. And interestingly, my father being a mechanic and having a mechanic shop, he actually would come home, and he could actually tell you when the local foundry was doing really well, and maybe when they weren't doing so well, just through his business, as a service business, as a mechanic. Mm-hmm. So the service businesses in our region, everything from the pizza shops to the auto repair shops to the car dealers, the dentists, the doctors, manufacturing drove that region and those service businesses. So over time, as employment numbers and these good paying jobs dwindled in our region, families started to struggle, service businesses started to disappear, and society truly started to fall apart. We even, started to have a lot of drug problems. Mm-hmm. And I knew from a very young age how important manufacturing was to our economy, our society in general, and our national defense. So growing up in that region and understanding that. Secondly, when I was a student in industrial manufacturing engineering at Penn State, my eventual graduate school advisor, Dr. Bob Voigt, was a metallurgist, and he was a Foundry Educational Foundation key professor. So Penn State University Park is a certified Foundry Educational Foundation school. So we were exposed to design, manufacturing, and finishing the actual castings right there in the lab on campus. Yeah. So it truly captured my interest. And then when I decided to go on to graduate school, I worked under Professor Voigt, who's a metallurgist. So my master's and PhD work was all metal manufacturing, material science, metallurgy, and I really, really worked on aluminum and steel. So that's really my background and how I got involved in, metals and metal manufacturing.
Well, I love hearing that background. I mean, it's like so many we hear, not only in Pennsylvania but Midwest, all throughout the country. And by the way, my father worked in a manufacturing plant for 40 years of his life, and so although they managed to stay in business the whole time, but so very familiar with these stories and interesting to hear how, and I think this is what we're going to talk about. This is what drives you as well to continue to make sure that this industry and these opportunities remain because they really do drive the economy in so many ways. So appreciate you sharing that. So you saw that growing up, big part of your life. You go to Penn State, you see this. Did you always know you wanted to be an academic, or did think you wanted to go into industry? What was the path to being a professor?
So really interesting. It's a great question, Ralph. I worked for a great company, Universal Forest Products. They actually had a location in the small little borough I grew up in. So, I learned working for them out of my bachelor's degree. I learned a tremendous amount. All right, as an undergraduate student, I worked as an intern in their design department, designing roof trusses while I was in college. And then that was more of a civil engineering type internship. Mm-hmm. And after I graduated, I was hired full time as a regional production engineer. And I received top-notch training by the company, and I was able to go across the United States and be exposed to all sorts of capital projects. And it was an excellent experience. But see, going back, when I was a student at Penn State, I worked as a tutor, and I also worked as an undergraduate teaching intern. Mm-hmm. And I missed the teaching piece. Mm. And I had an opportunity after, about a year back full time for Universal. Again, I had worked for the company as I was in college as an intern. Mm-hmm. I had an opportunity to go back to college on a teaching assistantship, which allowed me to teach manufacturing labs. I was able to conduct metals research and complete my classwork towards a master's degree. And Penn State funded that. Mm-hmm. And with that, I loved the teaching piece of it. And I love teaching the manufacturing lab. So after completing that master's degree, some of the faculty sat down and spoke to me about going on for a PhD. And I eventually did it. So that was the pathway. Why, though? That was the pathway to getting a faculty position where I could do what I love: teaching, advising, working on research, industry projects. Basically taking that next generation, right, educating them, working directly with industry, and pushing our manufacturing forward. And that's how I got there.
Yeah, and it's really important. You wanted to do that, but also someone tapped you on the shoulder, which was your faculty members, and they said, hey, we see some promise there. So I love hearing that part of the story, too. And as the record shows, you've won some really important teaching awards, and you have a great reputation as a very excellent teaching faculty member here. So let's talk a little bit about your path to Behrend, though. And all full disclosure, I think I was director of the engineering school when we hired you, so I remember some of those discussions. But you came here, you ended up here at Behrend in 2015, and how did that work? Why did you choose to come here? And what makes this the place for you?
Yeah, it's wow. We're going to start here in the fall. We're going to start year 10.
Year already. 10, wow.
So I could go on for a long time on this one. So as we know from talking today, I work in manufacturing, and I'm really passionate about working directly with industry partners and getting our students working in manufacturing while they're in school, right, to try to keep American manufacturing strong and help our local economies thrive. So really, I was always taught there's three ways for our local economy and our society to truly build wealth. You make it, which is manufacture it. You mine it, or you grow it. Erie and northwestern Pennsylvania is the make it.
Yep.
I was once told by one of my colleagues, and I believe this was actually on my interview. He said to me, Paul, if it cannot be made in Erie, Pennsylvania, it can't be made anywhere. Yeah. And now, as I just said, I'm going on year 10. That is a fact.
Yeah.
So for me, for the research I do on top of that, working directly with our metal manufacturers, and my teaching and advising, Behrend allows me to bring everything together.
It's great to hear that. It's a fit like that. Sorry, I interrupted you. Keep going.
Yeah, it allows me to bring together my research with the industry, with the students, and ultimately accomplish that goal that I talked about, right? Getting that next generation of workers, right, into the industry, get the newest practices in the industry, and introduce the technologies that we need to keep our manufacturing strong and then society strong. Right, in the area region. So In addition, I think one thing that's really important that I want to mention is the way Behrend works with industry. It's very unique for a Research One institution. It's truly, in my opinion, second to none, because the open lab allows me and my students to work side by side with local industry. And just to give one example, the local Northwestern Pennsylvania American Foundry Society chapter, along with a long list of other associations, a lot of industry partners, they have been nothing but supportive and helped us accomplish a great deal in 9 years, and we're going to continue to push that forward. But again, I can't stress enough how special Behrend is in the way, as a Research One institution, that we work with industry, and that is huge.
Really great observations. I didn't grow up in this area. I grew up in New York State. I spent my graduate work time in Arizona. Worked for industry for IBM, so a very different one. But your point about the ability and the mindset of people in Western PA to make things, it's amazing to me. It's part of the culture. And, I see kids come here and they go to the Innovation Commons, whatever it is, their ability and thought process, it really is different than you see in a lot of places in the country. And it's super, super important. And the idea, one of the things that you talked about was our connection with the outside world. And that's something that we never want to take for granted. But what's interesting to me is that, you have such deep connections with places like American Foundry Society. I'm looking at my stats here. They support more than 30,000 jobs in Pennsylvania, generate $6.7 billion in economic input. And where I'm going with this is, you can see people saying, "Oh, metal casting, forging sounds like an old technology." But let's talk about that, because I don't think it is. So, what do your students think about this, and how do you get them involved, and talk about the importance of this industry and where it's going?
So, is forging and casting, is it on the radar for every student? No. However, as I said, our region where we are, a large amount of our students have parents, grandparents, aunts, uncles, right, that have had a long and prosperous career in manufacturing. So manufacturing is not a dirty word to our students.
Nope.
And also, we have a significant number of first-generation college students here. And I'm proud of that, because I see a lot of myself in these students. Mm-hmm. And they understand the value of hard work, and they understand the importance of manufacturing to our local economy, society as a whole, and our national security. And kind of to end that piece of it about getting students involved, I'll never forget the first American Foundry Society meeting that I attended here in Northwestern Pennsylvania. And we sat down and, we were talking about some of the things that, manufacturing at one time, did we decade ago, 2 decades ago, maybe have people had a different image of it. We sat down and I said, you know what we need to do? Number one, we need to all work together and have a strong message. And number two, what I need from all of you is to offer our students an internship. Mm-hmm. I say give them an opportunity. And now, after 9 years of doing that, we have something very special moving forward. We have a pipeline of people going into the industry. We have students every month going out to the local Foundry Society dinners, meeting with the folks. We have our students competing at the national level. People know through the American Foundry Society where Penn State Behrend is. We took home one of the grand prizes again this year at the Steel Founders competition out in Milwaukee.
Congratulations.
But that took a lot of work, people working together, but what did it come back to? Giving students an opportunity.
Yeah. And you personally know these companies, and you get them to campus and talk about our career fairs, and I've seen it in action. You help students and you help them connect to the companies.
Yeah, that's huge to keep that constant back and forth in terms of a company calls. I get them in touch with career services. We work together. We get them in, and we try to make sure we're placing our students, and that is huge. And the other thing that's very important is very good communication and transparency. For instance, every month at the local Northwestern Pennsylvania chapter meeting, Shannon Sweeney and I, my colleague Shannon Sweeney and I, we're the education folks on the board. Mm-hmm. They get a full report of what's going on in manufacturing and metal casting, at Penn State Behrend, and that is very important.
So, Paul, I'd like to jump into some future-looking things, and first of all, start with some of the challenges that manufacturing industries are facing. Nearly 1/4 of manufacturing workforce is 55 or older. By 2030, we estimate that there are going to be 2 million unfilled manufacturing jobs in the U.S. But you're working with this organization called IACME, and we talked earlier about this very significant grant that you got, $4.4 million. And it's one of 17 manufacturing U.S. institutes that plans to address this. So why don't you step us through, what's the challenge right now? Let's talk about your grant, what you're planning to do. What's your future plan here with all that's going on with this very ambitious initiative?
I'm going to start with the challenge so that you mentioned, Ralph. Between now and 2028, our defense, the National Defense Industrial Base, they're saying they're going to need at least 122,000 additional shipbuilders, engineers, manufacturers, and other DoD support roles. That's a lot of people.
That's a lot.
That's a lot of people. And, failure to meet these needs, and to get our trades and our trade skill sets back up in this base metals industry, it really creates a vulnerability, right, for us. So it's extremely important. How are we going to address it? It's interesting. As this past year, I've spent a lot of time traveling across this country with IACME, speaking, sitting down with groups, and even with our really with our local groups here in Erie. And the thing that we decided was with IACME is we're going to train from K to gray. That's how we're going to do this. So starting with K-12 activities, we're actually learning from research that as young as 5 years old, kids are already thinking about what they like, what they might want to study in school, and careers. So we've already, launched the K-12 component. So we're starting there. As we go up, we're calling it a tiered curriculum and a tiered approach to this. So I just described K-12. We have a level 1, which is really an introduction. All right, that is online component, and it also is a hands-on boot camp component, but it's really introductory. 18 and up, just really introducing folks, all right, to the basics. After that, and in development, that's where we are right now, is level 1. There's a level 2 and level 3. And level 2 and level 3 is advanced, right, with targeted topics, company specific, and new technology integration. That'll also have online and boot camp components eventually. And maybe the most important piece of it is rebuilding, both on the government side and the industrial side, apprenticeships.
Mm-hmm.
So in Pennsylvania right now, along with our Penn State team, IACME and another party, third party, Jobs for the Future, they are right now, as we're sitting here talking, they're already working directly with manufacturers right here in our region to jumpstart their apprenticeships and their internship programs. So that is the tiered approach that we're taking to try to address this. Now, the last part of your question, what's the whole piece going to kind of look like, and how do we get here? Well, as I said earlier about the listening sessions, we sat down with the local metal manufacturing leaders here at least 3 times. The number one takeaway every single time was they need workforce development, was number one right across the board every time. And that's what this grant that you described earlier, this metal grant, that's exactly what this grant/contract is after. So where are we in kind of this tiered system of addressing this? Well, we've already launched the K-12 component, okay? About 1,400 people came through the STEAM fair on campus here in February.
Mm-hmm.
In the past month, we've had 5 metal sessions, hands-on activities, as part of College for Kids here on campus. About 100 students have already gone through it. Next week, we'll wrap up with 2 more sessions. So we'll have done 7 sessions this summer for K-12 as we're working through the curriculum piece of that. And as soon as we get the metal casting, the melting capabilities here on campus, we'll begin offering a 4-day metal level 1 boot camp for 18 and above here in northwestern Pennsylvania.
Wow.
So, and also the metal level, we're calling level 1, the basic online curriculum, that's already launched. It launched July 15th. And anyone can sign up to take it and earn a Credly badge for their completion. It's about 8.5 hours of training. It's 13 modules. It's free to anyone. Mm-hmm. You go to metalforamerica.org, and they can sign up and already do the level 1 training.
And it'll take them right to Penn State Behrend's training with IACME and all the work you're doing?
You got it. Medalforamerica.org.
Medal for America.
Yep. So
Spell out four or the number four.
So medal as in METAL, FOR, America.org.
Okay.
Yep.
Because I think some of our listeners who are going to hear this are in that industry and they're going to want to know where to go.
Yep.
And they can also always reach out to you. I hate to put the burden on you, but medalforamerica.org.
Yeah, so that's already level one. K-12 is already going on. Level one's already launched online, our beta version of it. Mm-hmm. And we're just about to offer the second beta level one boot camp in August at University Park.
Wow.
So now the last piece of that is level 2 and level 3, and they're coming down the pipeline. But they're going to be more focused for specific company needs and advanced technologies. And as I said, to end here, IACME and with us, with Penn State, and with Jobs for the Future, they're already working with local manufacturers to jumpstart these apprenticeship programs. The Department of Defense said, we need to do this. We need to fly the airplane while we build it. So we've been working hard.
Well, a lot of really, great things. And I want to go back and just ask a couple extra questions about what you said there. So when you talk about an apprentice program, and then in the same breath you said we need apprentice and internship. So what is going to define an apprentice program versus an internship? So can you explain to our audience what you're thinking about in terms of this need for apprentices?
So if we go back, let's go back to maybe the 1970s. So the Department of Labor has a list of apprenticeships, requirements, which are, at that point, they're called registered apprenticeships. So we have folks within IACME that are literally experts on apprenticeships that we're working with, and also with Jobs for the Future. And companies, when folks retired, they had the apprentice, right? They had people that were learning that trade behind them. Mm-hmm. And they were able to get through those cycles of retirement or job changes. And what happened over decades is we leaned out the workforce, mm-hmm. kind of did away with the apprenticeship programs, and all of a sudden, all our baby boomers are retiring. The country did way too much offshoring and outsourcing of our skills. And now we're at the point where, what do we do? Mm-hmm. What do we do? So the apprenticeships, registered apprenticeships, there's a certain time period that has to elapse, mm-hmm. okay, that you have to basically complete a number of steps, right, to complete that apprenticeship, whether that's hands-on training, whether some of it maybe is at a local community college, right, or trade organization or one of our camps here. But again, it depends, which apprenticeship it is, how long that apprenticeship is.
But you don't need a college degree. You
got it.
It's based on experience. Actually, and it's a very intentional. It doesn't take forever, but it takes some time to really develop that skill. It's a very kind of noble approach to developing the workforce too.
And there was really at one time when apprenticeships were strong, and like I said, what really being able to have that next generation ready, right? There was really three entities involved. The government, the Department of Labor has registered apprenticeships. You had the company itself, and then you had our unions. Mm-hmm. And they all were influential in those programs, and we need to get back to that. We need to get back to really, training folks and understanding that it's important to invest right in people and be ready for the future.
And what are the wages like here?
So
wages. I'm assuming wages are pretty good.
Yeah. So one of the things,
asking for a real, an exact number, but just
So what I've learned from working with I'm going to call the experts with IACME. There are folks that's what they've done their entire life. Typically, as folks go through and they're trained, their pay scale will go up.
Yep.
Right. So that I don't know exact numbers, but obviously as they progress and they get more skilled and they cross train, obviously that's usually a piece of it.
Well, the other thing you mentioned was K-12, and I'm piqued by you said on this campus this summer we've got some programs in metal casting going on. Can you take some young kids and having them actually cast metal and developing molds? What are you doing to keep them engaged for a week in one of these programs?
So what we've done is basically for the first time we've actually asked a few of the instructors, can we have one of your sessions? Because they all have 5 sessions, right? So for instance, we've worked with a high school teacher here that's teaching Chemistry 101. Mm-hmm. So we took one session, okay? and basically tied it to chemistry, right? Tied the metals to the periodic table, to chemistry, did a nice introduction, a couple of videos to capture the interest. These are 6 to 8 year olds. We showed them how their little die-cast car from the movie Cars is made. We showed them how they all told us, we got here in a car, we got here in a van today, or we got here in a truck. And we showed them the engine being manufactured, right? And said, you wouldn't got here today without metal casting, right? And they were asking all kinds of questions, right? And very excited. After that, what we actually allowed them to do was, we had someone working with either 2 or 3 of them at a time, and every single one of those students got to hand make a sand mold.
Wow.
We melted the metal. For safety, we just melted tin, allowed them to watch the pouring of it, to shake out of the mold, and all of them took home a cast part. And then they also took home a brochure about our initiative at Behrend and our initiative with metal for their parents and for their family. And they were very happy. Wow. So what we've done and we're going to do one more next week for 10 to 14 year olds. What we've also done is we've integrated additive manufacturing. So next week's camp, we're going to be 10 to 14 year olds, and we're going to integrate. They're going to get to do the hands-on casting, but also integrate additive manufacturing into it.
Wow, that is, that's awesome to hear, because most people have no idea how something like that is made. I know I would never have had a sense of it until later in life. So to see that at an early age, experience it, really great. Now I want to hit, we've got a few more minutes left in our discussion here. A few things that I wanted to still talk about is, one, I'd like you to talk a little bit about your research, and just tell me a little bit, so as a faculty member, you do teaching, research, and service broadly. You've talked a bit about your teaching and your passion there. Like, what are the problems you're looking at, and how would you explain that to a layman?
So primarily, I work in industrial manufacturing engineering, also a faculty member in our Master of Manufacturing management program. And I explained already today my kind of background and having worked under Professor Boyd at University Park and his metallurgical background. And so most of the work that we're doing is metal manufacturing. We are big on physical metallurgy. So we actually from design all the way through the end testing and looking at the metallurgical structure of the materials that were produced. This is a big focus of what we do. And one of the things I think that has happened in the past couple of decades is we've relied heavily on simulating and simulations. And we're talking with our local companies, it's not uncommon once a week that I get a call from a local company. Hey, Paul, do you have an idea why this might be happening? Or they send me a sample in the mail, right? And one of the things I found over time is simulation is like going to a baseball game. The simulation will get you in the stadium, right? But it's the actual physical metallurgy and understanding the structure and understanding the process that'll get you to your seat. And I think for years, I think there was a big gap there. And I think at Behrend here, with the labs that we've had, we've developed a really nice materials lab, right, in the Advanced Manufacturing Innovation Center. And so we spend a lot of time doing the physical metallurgy piece and working directly with manufacturers. So right now, to kind of fully answer your question, we have 3 larger funded efforts. One is with one of our local companies, and we are looking at everything from efficiencies, material selection, characterization, and the physical metallurgy piece on that side, all the way over to studying emissions. Can I put $1 on this, but also can I put emissions factor on it? So that's one project. Another project we're working on, we're trying to develop, across the world, we have a deficit of scrap material. And we're in a battle across the world for certain elements. Can we develop materials at a lower cost, mainly steels, at a lower cost that have high strength, hardness, ductility, and toughness? So we've been working on that and trying to also make sure that we can get the elements we need and develop the chemistries for it and the processes. That's a second project that we're working on right now. The last one here, the large one we talked about, is really the workforce development, the metal effort that we talked about today. And as I said, the listening sessions with our local manufacturers, they said, we need this.
Well, that is a significant amount of of work and body of research. So let's take that to the next level. We've got this project here on campus known as Project Resolve that's well known in the community. And we're working on the creation of a new Center for Manufacturing Competitiveness. And not surprising, you're in the midst of all of those efforts. So why don't you talk a bit about, the project, but, really specifically, what is the Center for Manufacturing Competitiveness and what do you see happening there? What are you trying to make happen in the center?
We've been, as you know, Ralph, we've been working for a long time, right, on CMC, Center for Manufacturing Competitiveness. And I kind of want to dovetail that thought into what we're doing with metal. This project, metal, that's at the heart of our Project Resolve. And within Project Resolve, that's where our Center for Manufacturing Competitiveness is planned to house. It's going to house a new additive manufacturing and metal casting facility, along with a battery test facility. We're talking about an AR and VR lab, virtual reality, and an advanced polymer recycling and characterization center here on campus. And specifically looking at the additive manufacturing and metal casting facility, the ultimate goal of that facility, as we sat down over years, and again, this is industry driven. We sat down in listening sessions with local industry, and said, okay, what do you need? And outside of workforce development, it was that next generation of technology to make them competitive. So really, I think it's kind of three pieces. We want to position our Pennsylvania metal industry to be competitive, as I just said, both nationally and internationally, and really keep jobs right here in Erie within our region. And also maintaining our environmental quality, right? That's a big piece of it. So these specific goals and objectives are really going to be met, like I said, with three deliverables, I would say. One is that development of the advanced additive and metal casting lab here at Behrend to be used as a sandbox with our local metal industry, right? To work on projects that allow the manufacturers to train on the new technology, adopt these new technologies into their businesses, okay? Why is that important? Not only are you adopting and training, but if you look at the breakdown of the forging and metal casting industry in the United States, you're talking 80% small to medium-sized businesses. A lot of these folks don't have the capital money sitting around and go out and spend millions of dollars, right, unless it's a proven technology. Well, the proven piece comes from working in our sandbox. And then they go out and adopt it, and they purchase their own equipment, right, and their training. That's huge. That's huge. Secondly, it's that dissemination of that new knowledge to the metal casting community and our forging industry, all right, through our trade organizations and our workforce training organizations. And then what are we doing on campus every day? We're training that next generation, right, of our engineers and our technicians to work in the Pennsylvania metal industry, right? Both, through training within the Penn State Behrend metal program, and also with, having industry-specific job fairs and student nights to bring the industry in to offer internships with their companies, offer co-ops, and offer full-time positions. So this thrust in the areas of education and research and manufacturing within this Center for Manufacturing Competitiveness, that's right at the heart of overall Project Resolve. It's right at the heart of the metal program. And most importantly, it's right at the heart of what our region is asking from us.
Well said. And I think, you hit on so many important points there. And you mentioned as well sustainability. And I don't think that that's fully understand that these gains, by the way, I'll just, add a little bit here. A lot of people ask me about greenhouse gases and, sustainability. And I don't think most people realize in the United States, actually, the greenhouse gas emissions have actually been going down. And per capita, they've actually been going down since the 1970s. Now, this is a significant problem that we need to address. But my point is, you're addressing it in the center, too, by helping them adopt new technologies that are better for the environment, reduce energy, fewer emissions. But in the end, we all know, whether it's an electric car or whatever the vehicle is, we're going to cast and forge some parts for that, and it requires energy. And my point there is it's important, sometimes seemingly slow, but it's not that slow. That work is actually really happening. So I love to hear that.
Yep. And interestingly, as I kind of ended on the research piece, in the past couple of years, as I said, we undertook, a project, and basically, every Friday morning I have my, materials and manufacturing group research meeting. You go back from the past 2 years, kind of every deliverable we worked on a week before, it kind of was, okay, tell me cost, and right aside of it, I want to know emissions. Because all the way through the supply chain, when you look at steel, especially today, there's questionnaires going through that supply chain. People are being forced to answer those questions about their facilities.
Oh, yeah. Well, we have had a wonderful conversation. We're almost to the end here, but is there anything you'd like to add? I'll give you the last word. Anything you'd like to talk about, Paul?
First of all, I want to thank you for allowing me to come here and talk today. But really what I want to do, okay, at the end here is just thank all our partners, all right? Whenever I go to a meeting, I don't like to use the word I. It's we, and I just spoke about this at a local fundraiser. I said, what we've accomplished in 9 years, and we're going to continue to do, we all did together. It took bringing together the local manufacturers, offering the internships, offering the co-ops. They put an endowment fund together here. They put money together and put a scholarship endowment fund together for our students working in industry. If we call and we need senior projects or we need some consumables in our labs, they're helping. I just want to thank everybody. Northwestern Pennsylvania AFS chapter, the Foundry Educational Foundation, Pennsylvania University Cass-Manel's Advisory Committee, and many, many more. The companies. We could not do this alone, but we are working with these folks day in and day out, and they're telling us what we need, and we're delivering. And I want to see it continue forward. So I just want to thank everybody in this region for all the help.
Well, I'd like to thank you as well for your role in this, as well as all of those who are supporting us. This has been a great conversation. I'm Dr. Ralph Ford. You have been listening to Behrend Talks, and my guest today has been Dr. Paul Lynch, Associate Professor of Industrial Engineering here at Penn State Behrend, leading a lot of initiatives in metal casting. And Paul's easy to reach. He's here on campus, so I think if listeners have any questions, feel free to reach out to us. Again, thanks for joining us, Paul.
Thank you.